So, welcome back. We're about to try arrayChange here. So let's take a quick look at that. Okay, so what are they asking us to do for arrayChange?
You are given an array of integers. On each move, you are allowed to increase exactly one of its elements by 1. Find the minimal number of moves required to obtain a strictly increasing sequence from the input.
A strictly increasing sequence? Well, okay. So I just had a flashback to a previous challenge here. Where have we heard about those? Oh yes, almost increasing sequence. So we found that this was a pretty tough one. I keep referencing it because it's kind of the hardest one we've encountered so far. I mean, it was really the only one where we've really had to reorganize and reconceptualize our algorithm because of time complexity. So we're going to see other ones like that. Well, actually, there's there's one other one that's coming to mind where it's going to pose as big of a challenge as this, and it's number 33, but we won't get there for a little while. The main thing is that this was all about strictly increasing sequences. Our next one is all about strictly increasing sequences, so maybe we'll have to brace ourselves. Maybe it's going to be tough like that last one was. What is a strictly increasing sequence again? Well, it's one where the numbers go up every time and not down and not staying equal. So they go up by some amount. Maybe they go up by 1. Maybe they go up by like 20. It doesn't matter. But as long as they're increasing every time, then we consider that a strictly increasing sequence. Okay, so basically the way this one is working is we'll go from left to right, and on each move we need to increase, or we're allowed to increase one element by 1. And we want it to become strictly increasing. So right now this one, is it strictly increasing? No. It's not decreasing, but it's not strictly increasing. That's the issue. So we would need this one. Well, if this one's going to be 1, and we can only add numbers, we can't subtract, so this one needs to be at least 2, right? If the first one is 1, this one has to be at least 2. Okay, so we're going to add 1 to this one. But if this one's going to be 2, then this one needs to be at least 3. So we need to add 2 to that one. So basically we'll add 1 to this one and then 2 to this one for a grand total of 3. Okay. Pretty straightforward. I think that makes sense. So basically the way we're going to do this is we're going to top up each element so that it's at least as big as the previous one. And then we'll do the same thing for the next one. That's basically it. So we're going to do this in place. We're going to do this in a way that we actually do modify input array. We're not going to store a new array in memory. And we're going to do this variable let additions be assigned the value 0. It's going to start at 0, and this is just going to keep track of the numbers that we're adding here. Okay, so we're going to say for let I be 1, I is less than input array dot length I plus plus. Why 1? Why not 0? Normally we start at 0. Well, in this case, we sort of know, like, I don't want to touch that first element, right? I'm not going to add anything to that first element because that's just going to make our job a lot harder. So, and we know that we can't subtract anything from it. So basically, we're going to use 1, and we're basically going to say let goal be assigned the value of input array at I minus 1 plus 1. Okay, so y minus 1, y plus 1. Let's talk about this first. So I minus 1. I'm basically saying for each element, and we're starting at this one, we want to compare it to the previous one. So what was the value of the one before it? And then we need for this one to be at least 1 bigger than that, because that would mean it's strictly increasing. So that's why we're doing the plus 1. So the minus 1 is saying, talk about the previous element. The plus 1, since it's outside of the brackets here, that means we're adding it to whatever value this one has at the previous index. Okay, so that's our goal. And then basically we want to do another for loop, and we'll just say, actually, maybe a while loop. Yeah, so we'll do a while loop, and it's going to be while input array at I is less than goal. So while that's the case, we'll say input array at I plus plus, add 1 on, and additions plus plus. We're adding 1 on to that as well. And then we'll just go through that, and at the end, we'll return additions. Let's see if that works. Okay, well that's not too bad. That seems to be working. It seems to be passing all the tests. Okay. Well, I wonder if it's going to work. So, I'm looking at this now and I'm noticing like the numbers inside the array can be pretty damn big, and then the length of the array itself can be pretty much just as big. They can each be like 100,000 elements. Well, the numbers inside could be as low as negative 100,000, as high as positive 100,000, so technically it covers twice the range, but the main thing is they can both be pretty big. So maybe we're going to have to worry about the time limit exceeding when we actually submit. Maybe there's going to be some hidden tests that are going to... Oh. Well, okay. I was expecting a little more resistance for that one, but we'll take it. And, oh, look at this. We're on to recruit 4 now. That's pretty not bad. So a couple more of these and we'll be up to a trainee pretty soon. But anyway, thank you all for being part of this. It feels good. All right, we'll move on from that. So let's see if we can change our algorithm a little bit. What would we want to change about this algorithm? Well, is there anything wrong with it? I don't know. Like, it passed all the tests. It didn't seem like there were any major issues. Could it be better? Just a little bit. Just a little bit. And the reason I say that is because if you think about what we're doing here, we're kind of saying our goal for this one, for input array at I, our goal is going to be this thing. So we know what we want it to end up being. But then in terms of how we're reaching that goal, we're doing something that's like, I would argue kind of inefficient. And the reason I say that is because we're adding one on each time, right? We're just add one, add one, add one. But we kind of already know how many we want to add. This is like if you go to a grocery store or something like that and you want to, I don't know, buy a bag of peanuts, and instead of taking a whole handful, you just take out one at a time. Like that, it would take forever, right? So basically the idea is that, especially just considering that these numbers can be like 100,000, right? And you could have one that's like going from negative 100,000 to positive 100,000. So this loop could be going for 200,000 iterations. I find that to be too many. I feel like that's more than would be necessary. So basically the way we'll do it is, well, there are a few ways we could do it. We could basically say something like input array at I is assign the value of goal. Let's just say I'll give you that, But before we do that, I sort of want to use this old value to say additions, and we're going to add on to additions. How much are we going to add on to additions? Well, basically, whatever the goal was minus whatever the value was, whatever was in there already. So we're just going to add that on, and then input array is going to reach goal. So now we don't need to worry about looping through it. We'll just make it happen with just one mathematical operation. And now, uh-oh, it's not working the way it should. Why not? Okay, so we're having a bit of an issue with this one. We're getting a negative output, and that definitely seems wrong. Yep, that definitely seems wrong. Okay, so why is this behaving this way? Well, let's think about it. It was working just fine before. So we're starting at the 0 here, and we're basically saying our goal. Okay. So the problem here is that the goal would be like negative 999, right? We don't actually want to add that on here. So maybe our goal should be something more like math.min or math.max. Yeah, math.max of input array at I minus 1 plus 1. So like, whatever the previous element was plus 1, or just, whatever we have in there already. Yeah, whatever I have. Because, okay, in this case, we're saying, well, it goes up to a 0. So now the goal, instead of being negative 999, it'll be 0. because that's a bigger value than negative 999. And then from here, it'll say, well, additions plus equals goal minus input array at I. Well, goal was input array at I, so it's going to add 0 onto additions, and then it's going to make this goal. Well, goal is already what it was. It was the element, so it's not going to change anything in that case. So will this work? Let's find out. Okay, great. That works. Will it work for all of them? I can't see why it wouldn't. I mean, it should be more efficient than the one we had before, so great. That's nice. Could it be more efficient than that? I think so, but just a little. So, yeah. Yeah, I think we could modify it in such a way that would make it like a little more efficient, like probably just negligibly more efficient. I don't know if this is going to make a big difference at all, but I'm just thinking there's got to be a way we could do this without actually changing input array at I, or without changing input array at all, I guess is what I mean. So let's just say let last num be assigned the value of input array at 0 to begin with, and then we'll compare to last num over here. Last num, and then instead of saying input array at I is goal, we'll just say last num is goal. And will that work? Yeah, that works pretty good. So is that the best one? Yeah, I think that's the best one. I think this is the best one we're going to find, at least for the way we're doing it right now. Maybe there's an even better way that just makes way more sense than any of these, but I think these are good enough. You know, it's passing all the tests. It seems like it's not taking too long to do that. So I guess that's it for this one. Yeah, I don't think there's really much more to be said about it unless anyone has any questions. Let's see. Yeah, I mean, it seems like it's working. We're basically just filling in the missing parts. So. Okay, and by the way, just to sort of close the loop, I guess, for this one, the reason I like this a little bit better is if we were to return input array at the end of this one, it wouldn't be any different than it was at the start of this one. We're not actually modifying any of the values. Because, I mean, the reason I want to point this out is because you might look at this and compare it to this one and say, well, isn't this one worse in terms of memory? Because you're keeping last num in memory now. There's like an extra variable that we didn't have before. But I think that's better than actually modifying the array. I mean, some people are kind of touchy about this idea of mutating data at all. You know, like functional programmers don't want to ever mutate data. So I'm getting the sense that it's probably a good thing to sort of steer away from if possible. But anyway, I think we're probably good for this one now. So we'll move on from here. Nice job, everyone. Okay, so that leaves palindrome rearranging.